Now we're looking at polarization of a polar dielectric. So one question that should come to your mind, that is, when it's already polarized in some sense, right? There is positive and negative, that is the cloud of the electron and the nuclei, they are not overlapping, so on and so forth. When that is already happening, when it gets exposed to the electrical field, so what changes? Well, the alignment changes. Here, say the dipole moment is in this direction, so on and so forth. Those will align in the direction of, almost in the direction of electrical field. So as and when the strength increases, the alignment will get closer and closer to the direction of the electrical field. So basically in this case, the molecules are already polarized, so the energy is used up to make them align. Essentially being used up for torque, right? It is turning. So things are turning around. So how polarization occurs over here? When a polar dielectric is placed in an electrical field, its permanent dipoles tend to align with the field. They try to. This alignment enhances the overall polarization of the material. The net effect is that the overall material looks like it's becoming a dipole. At one end, we are looking at a lot of positive charges. Other end, we are looking at the net negative charges. While the dipoles may already be oriented randomly, the external field extends a torque on them, causing them to rotate and align. So basically, we are using up the energy in this process. So now let me put it across. See, the funda over here is that what we are trying to do here is we are trying to increase the capacitance of the capacitor. That we can do so by altering the space between the capacitor. So one of the material that we can use is a dielectric. Within that dielectric, we have two different scenarios, a polar and non-polar. So we need to understand that where exactly this energy is going. What exactly is happening within those dielectrics? What different things are happening? So that we can make use of it better, so that we can understand the math better, so that we can imagine things better. That's what we're trying to do. Now, in this video, we are looking at polarization of a polar dielectric. So polar dielectric, the property is that the atoms, when you take up individually, they're already having the positive and the negative, they're separated. On an average, electrons are spending more time at one end than the other end. So herein, when we apply the electrical field, what different happens? The atoms and the molecules, they tend to align in the direction of the electrical field. So as and when you increase the electrical field strength, the alignment will be more. So basically, energy is used up as energy is used in turning this set of atoms and molecules.